Jai Hind to all. I am Updesh Kumar Jaiswal, working as an assistant professor in Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College. Today, I am going to discuss about the topic data encryption standard, that is the DES and triple DES. It is related to subject data encryption and compression. The subject code is STCS 501. So, firstly, I want to give the introduction of data encryption standard. It is a symmetric key algorithm for encrypting the data. Symmetric key algorithm means both the key are same and they are secret. DS was firstly published by the National Institute of Standards and Technology NIST. In DS, we encrypt data in 64-bit blocks using a 56-bit key. In the general structure of DS, the encryption process is made of two permutations, which we call initial and final permutation, that are inverse of each other, and there are also the 16 Feistel rounds. DS process overview. In this, data is encrypted in 64-bit blocks using a 56-bit key. It uses a Feistel network structure with 16 rounds of encryption. In each round, expansion, key mixing, substitution, permutation and swapping occur. This is the overview diagram, encryption and decryption with DES. Here DS cipher, DS reverse cipher, 56-bit key is used, 64-bit plain text and then 64-bit cipher text is obtained. Here encryption is performed and this side decryption is performed, DS reverse cipher. So it is the overview of the complete DS process. General structure of DES. So 64-bit plain text is converted into the 64-bit cipher text using the 16 rounds, and initial permutation performed in starting, and finally the inverse of initial permutation, that is the final permutation, is performed using 48-bit key, that is from K1 to K16. It is represented here. So this is the general structure of the DES. There are 5 main steps in DS encryption process. First is initial permutation, that is represented by IP, splitting the data block. Third, key transformation and key scheduling. Fourth, 16 round of Feistel network structure, each having the expansion, key mixing, substitution, permutation and Feistel swap. And in the fifth step, final permutation, that is the IP inverse is occurred. So in step 1, initial permutation, that is IP, DS start by permutating, rearranging the 64-bit plain text block using a fixed table. These initial permutation ensure that the data bits are scrambled before encryption begins. The IP rearranges bits based on a predefined pattern, creating a mix of the data that is used as the input to the first round. For example, the bits of input data are permutated based on the IP table for the encryption. Step 2, splitting the data block into left and right halves. After the initial permutation, the 64-bit block is split into two 32-bits half. There is the left half L0, right half R0. These two halves are processed separately and undergo transformation in each round. Step 3, key transformation. The 56-bit key is transferred into 16 sub keys of 48-bit, one for each of the 16 rounds. Key scheduling, DS uses a key scheduling algorithm to derive these sub-keys. Example, for a 56-bit key, 16 sub-keys, that is the K1, K2 up to K16 are derived for each encryption round. So, step 3, key transformation and key scheduling are performed like this. Step 4, Fistel network. This is the 16 round of Fistel structure. DS encryption proceed with 16 rounds, where each round consists of transformation using 48-bit sub-key derived from the original 56-bit key. Each round applies for the following steps, that is the expansion, key mixing XOR, substitution S-box, permutation P-box, and Fistel swap XOR with left. So, these are the steps with each round. Now, in step 5, final permutation, that is IP inverse 1. After completing all 16 rounds, recombine the left and right halves, perform an inverse of the initial permutation, that is IP inverse, to get the final encrypted 64-bit block as a output. So, initial and final permutation are represented using this diagram, that is the figure 3. Here 1 is substituted with 8, 2 is with other, and in the reverse same process occurred. So, 1 goes to this, 2 goes here, 3 goes here, and in the reverse again to get the original 40 comes at the 1st, 8 come at the second position, and finally 64 bits are generated. So, this is the final initial permutation, and this is the final permutation. Key generation. The round key generator creates 16 48-bit keys out of a 56-bit cipher key. So, key with parity bits, 64 bits, parity drop, cipher key using the 56 bits, divided in two parts, shift left, shift, then compression P box, shift left, 28 bits, compression P box. So, these are the rounds 1, 2 up to 16, and finally compression P box. So, we can say round key generator, and this is the figure 4 for the key generation. In DS, 16 rounds are used. Each round of DES is a Fistel cipher, 32 bits left, 32 bits right, and FRI1, RKI1. So, swapper mixer, and these are the round L1, LI, RI, 32 bits, 32 bits. This is the figure of a single round in DES. That is the for the encryption side. Now, DES function. The main thing in DES is the DES function. The DES function applies a 48-bit key to the rightmost 32 bits to produce a 32-bit output. So, here DES function is explored here. FRI-1, KI, input 32 bits, expansion P box 48 bits, XOR then 48 bits, S boxes then 32 bits, state P box then 32 bits, then output. So, this is the whole DES function. Now, what are the advantages of DES? Simplicity and speed. DES is relatively simple to understand and implement, making it a popular choice for straightforward encryption tasks. It operates on 64-bit blocks, making it fast and efficient for different area. Widespread adoption. This is the second advantage. DES become a standardized encryption protocol. Symmetric key algorithm, as I have already told, DES uses the same key for the both encryption and encryption. Both are the secret key. So, here symmetric key algorithm is performed, and basis for further development. So advanced encryption standard can be implemented using the DES. There are always some negative side of everything. In such a manner, the limitation of DES are short key length of 56 bits, vulnerability to brute force attack, outdated security, limited block size, and susceptibility to certain cryptanalysis attacks. These are the 5 limitations, drawbacks of the DES. So DES with 56-bit key length make it vulnerable to brute force attack. With modern processing capability, DES 56-bit key spaces is too small. DES was developed in 1970, so it is very outdated. The 64-bit block size used in DES is smaller than the modern encryption algorithm, which makes it less efficient. And DES physical network structure, while robust for its time, is vulnerable to differential and linear cryptanalysis when used with certain weak key sets. So these are the 5 limitations which I have discussed. So due to these limitations, the concept of triple DES was introduced. Triple DES in short is called as a 3DS or TDS, is an encryption algorithm that applies the data encryption standard encryption process 3 times to each data block. 3DS was developed to enhance the security of DS, which became vulnerable to brute force attacks as computing power increased. And the main feature of triple DS are it applies DS 3 times to each data block using either 2 or 3 keys, significantly enhances security over single DES and provide more security by increasing key length, making brute force attacks less feasible. So chances of brute force attacks will be minimum. So in case of triple DES, we perform 3 rounds of DES: encryption, encryption, decryption, then encryption, to make it more secure than single DES. So encrypt the data with key 1, then decrypt the data with key 2, and again encrypt the result with key 3. So K1, K2, K3 are 3 keys. So we can say the working of 3DS is represented here. The original message is good day, and key 1 is applied and encryption is performed, then ciphertext 1 is obtained, then ciphertext 1 goes on the another stage and key 2 is applied on this ciphertext 1, then cipher 2 is obtained using the key 2. Here decryption is performed, then again encryption is performed using the key 3. So key 1, key 2, 3 stage locking system, making it more secure. And then ciphertext 3. So this is the working of triple DES. Key option in triple DES, I already told, 3 key 3DS, 2K 3DS. So 3K DS uses 3 independent keys, that is the K1, K2 and K3, but 2K 3DS uses only 2 keys, that is the K1 and K2, where K1 is equal to K3. So 2 keys will be similar. So we can say triple DS is divided into 2 categories: triple DS with 3 keys, triple DS with 2 keys. Now I am showing in figure 7 triple DS with 3 keys, that is the K1, K2, K3. Here DS is performed using the K1, K2 and K3. Here DS -1 because encryption, decryption, then encryption. So DS1, DS, DS, DS1. This is the reverse of this. So DS1 reverse will be DS. So this is the whole process how the triple DS work with the using the K1, K2, K3 keys. In figure 8, I have shown triple DS with two keys K1 and K2. Here two keys are similar, that is the K1 is equal to K3. Here 64-bit plain text, then DS cipher, DS reverse cipher, DS cipher, encryption is performed 64 bits cipher text. Here K1, K2 and K3 is equal to K1. So again K1, DS reverse cipher, DS cipher and DS, both are the reverse process at the encryption and decryption side. So this is the triple DS with using two keys K1 and K2. So using these two methods, using these two ways, we can do the triple DS, and both are represented by two separate diagrams. So a simple example of triple DS, if the plain text is hello world and the keys are K1, K2 and K3, then encrypt hello world with DS using the K1. So we obtain the cipher text 1, as I already shown in this figure. Similar type of example. Decrypt cipher text with DS using K2, then we will obtain cipher text 2. Encrypt cipher text 2 with DS using K3. This is the final cipher text. So this is the one of the simple example of the triple DS. Now advantages of triple DS. Triple DS is an encryption algorithm that applies the original DS algorithm 3 times to each data block, offering several advantages like enhanced security, compatibility with DS, widespread acceptance, extended key length and backward compatibility. So these are the 5 main features, main advantages of triple DS. Triple DS is more secure than the original DS, as it uses 3 stages of encryption with different keys K1, K2, K3. Since triple DS is based on the original DS algorithm, it is compatible with systems that already use DS. Triple DS has been widely in various industries, particularly in finance. It has been recognized by standard bodies and included in the cryptographic protocol. So it's a well understood and trusted solution. Extended key length with a total key length of 168 bits, 356-bit DS keys, 56 multiplied by 3 times then 168 bits. Triple DS provides significantly stronger encryption than DS, which uses only 56-bit key. This makes it more resistant to brute force attack. Due to presence of 3 keys, we allow compatibility with the single DS implementation for easier transition to stronger encryption without altering the entire infrastructure. Now I am going to compare between the DS and triple DS. Triple DS significantly increased security compared to single DS by combining multiple encryption and decryption steps, making brute force attacks impractical due to increased key length. However, triple DS is slower than DS and is primarily used for application requiring legacy support. However, both are now being replaced by the advanced encryption standard. A comparison between the DS and triple DS is given in this table, where in the first column I have mentioned the features on the basis of which differentiation between comparison between DS and triple DS is performed. So first feature is key length. In case of DS, the key length is 56 bits, while in case of triple DS, that is the 3DS, the key length is 112, that is, or it may be 168 bits. Encryption, here single encryption, here encryption, decryption, then encryption in the sequence. So not a single encryption, there are 2 encryption and 1 decryption. Block size, DS uses the 64-bit block size, and block size are similar in both the cases. Security, so weak by 2 days standard. In case of DS, due to 2 days standard, weak security is provided, but using the triple DS, much stronger security is provided than triple A. Performance, So DS is more faster as compared to triple DS. DS uses are absolute and insecure, but triple DS used in legacy system replaced by AES nowadays. So I have discussed about the DS and triple DS, and to make this lecture I have used these references. Thank you and Jai Hind to all.